Good day everyone, I am Jalmi Dicagais and I will be the second reporter for today's presentation. I will be discussing the next part of our topic, designing relational databases. Database design is a component of a much larger system development process that involves extensive analysis of users' needs, which was the topic of Chapter 5. The focus will be in the following 6 phases of database design, which are collectively known as view modeling. First, identify entities. Second, construct a data model showing entity associations. Third, primary keys and attributes to the model. Fourth, normalize the data model and foreign keys. Fifth, construct a physical database. And sixth, prepare the user's views. View modeling begins by identifying the primary entities of the business function in question. Recall that the entities are things about which the organization wishes to capture data. First, the purchasing agent reviews the inventory status report, figure 8.15, for items that need to be recorded. Second, the agent selects a supplier and prepares an online purchase order. Third, the agent prints a copy of the purchase order, figure 8.20a, and sends it to the supplier. Fourth, the supplier ships inventory to the company. Upon its arrival, the receiving clerk inspects the inventory and prepares an online receiving report, figure 8.20b. The computer system automatically updates the inventory record. The next step in view modeling is to determine the associations between entities and document them with an ER diagram. Recall that associations represent business rules. Sometimes the rules are obvious and are the same for all organizations. Add primary keys, the next step in the process to assign primary keys to the entities in the model. The analyst should select a primary key that logically defines the non-key attributes and uniquely identifies each occurrence in the entity. Figure 8.24 presents a normalized data model. Normalizing the data model and adding foreign keys means organizing the database to remove duplication, avoid errors, and clearly connect related tables. Normalization improves the data integrity and makes the system more efficient. Construct the physical database. Figure 8.25 illustrates the table structures for data use. The primary and foreign keys linking the tables are represented by dotted lines. The following points are worth elaboration. Constructing the physical database means turning the logical data model, ER diagram, into actual database tables that can be implemented. Preparing the physical user views means making sure the database tables can support the screens, forms, and reports that users needs. Prepare the physical user views. The normalized tables should be rich enough to support the views of all users of the system being modeled. Global view integration means combining all the different user views from every department, like purchasing, sales, inventory, accounting, and etc., into one complete company-wide data model. Commercial database systems help make this process easier. Designing a full company-wide database from scratch is difficult and time-consuming.
Good day, Ma'am. I am Rhea Lincanoy, the presenter about Embedded Audit Module. Embedded Audit Module is also called Continuous Auditing, is a tool built inside a company system to automatically capture important transactions while they are being processed. So, this helps auditors quickly identify significant transactions and reduces the time needed for substantive testing because the important data is already collected in real time. So here in the figure 8.26, the embedded audit module technique. So this technique works within a production application to monitor transactions as they are processed. Production transactions enter the systems and are processed normally, updating the production master files and generating production output for users. At the same time, the embedded audit module operates inside the application. The auditor sets a materiality threshold to determine which transactions should be captured. Transactions that meet or exceed this threshold are automatically copied into an audit file. The auditor then reviews the audit file and prepares a list of materials, transactions for use in substantive testing. This process allows important transactions to be identified in real time without interrupting normal system operations. There are two disadvantages of embedded audit module. First is the operational efficiency, and the second one is the verifying EAM integrity. So the first one can reduce system performance because they add extra processing work to the host application, especially when extensive testing is conducted. Although the module can be turned on and off to reduce system burden, doing so may lessen its effectiveness as a continuous audit tool. The second one, which is the verifying EAM integrity, can be a concern in environments where systems are frequently updated. Since EAMs are embedded within the host application, any changes to the system may require modifications to the EAM as well. If not properly maintained, this can affect the reliability and quality of the audit process. Therefore, auditors must regularly evaluate the integrity of the EAM, similar to how they test application controls. Generalized audit software. So, it helps auditors check data, extract reports, select samples, compare files, and recalculate fields. It's easy to use, work on any system, and allows independent testing. So, in the figure 8.27, using GAS to access simple file structure, this is the most widely CAATT for IS auditing. It allows auditors to access electronic data files and perform tasks such as checking totals and balances, extracting and reporting specific data, selecting statistical samples, formatting results into reports, printing confirmations, screening data, comparing files, and recalculating fields. The general audit software is popular because it is easy to use even without extensive computer knowledge, works on both mainframes and PCs, allows auditors to perform tests independently of client, IT staff, and can handle most types of data files and formats. So this is the simplified file structure. So this diagram is how generic auditing software interacts with a simple flat file system during an audit of production inventory. An auditor defines selection criteria such as a materiality threshold and key fields. The next one is the GAS uses this criteria to extract specific data from the production inventory file, and the software generates a list of items for physical counting as part of substantive testing. And the last one is the process results in a transaction list used for further auditing procedures. 8.28 using GAS to access complex file method. So, the diagram illustrates the four steps uses with the generalized audit software to access data from a complex database structure. So, the process involves converting the complex database into a flat file that the GAS can read, which is necessarily because most audit software is designed to work with simpler file formats. So for the step 1, which is the auditor specify which database records to copy into flat file. So the auditor specifies which database records are needed. Step 2, a database management system utility program extracts the specified records into a flat file. And the step 3, the auditor defines the specific selection criteria for the GAS to use on the flat file. And for the step 4, which is the GAS retrieves selected records for the flat file. The GAS retrieves the selected records to produce a transactions for the auditor's review. Figure 8.29, the complex database structure. This complex database structure illustrating the relationships between different data files in a business system. Customer file, sales invoice file, line item file, and the pointers. The first one, which is the customer file, stores customer-specific information such as ID number, the name, address, and the current balance with pointers to link sales invoices and cash receipts. For the next one, which is the sales invoice file, contains invoice detail like invoice number, the amount, and shipping date connected to specific customers and line items. Line items also list of individuals, products, or services purchased within an invoice, including item number, the quantity, the unit price, and the extended price. And the last one, which is the pointers, arrows represents database pointers that links records across different files to maintain data integrity and enable navigation between related records. The next one is the audit issues pertaining to the creation of flat files. Relying on IT to create flat files can risk data integrity as important or suspicious data might be omitted. Auditors with programming skills can extract data themselves to ensure reliable audit evidence. So, relying on IT department to generate flat files poses a significant risk to data integrity, as critical or suspicious information can be intentionally or accidentally omitted during extraction. This lack of control compromises the auditor's independence and the reliability of the evidence. To mitigate this risk, it is essential for auditors to have the programming skills necessarily to extract and verify data themselves, ensuring a complete and accurate foundation for their audit conclusions. The next figure is all about flat version complex file structure. So figure 8.30, the ACL software is a leading GAS used by public accounting firms. It lets auditors access and analyze client data in various formats with ODBC support, solving many complex data access issues. The software's features are applied in audit procedures and reinforced through hands-on assignments using university sites licenses. So this figure illustrates how auditor software maps client data. So ACL software is a leading generalized audit software used by public accounting firms to access and analyze client data in various formats. The data analysis, the software allows auditors to solve complex data access issues using ODBC support. And the last one is the audit procedures. These features are applied to audit procedures and reinforced through hands-on assignments using university site licenses. The next figure is the figure 8.31, the data file definition. So, in ACL data definition, auditors defined file location, structure, and fields in ACL, allowing easy access and analysis of data from various formats. So, this figure illustrates a data file definition screen. A process where auditors specify the location, structures, and fields of a data file within the ACL software. So the purpose of this figure is to allows for easy access and analysis of data from various source formats. Figure 8.32, the view of inventory table. Customizing a view, ACL lets auditors create new views of a file. Showing on customizing a view lets auditors create new views of a file showing only relevant data and rearranging fields for easier analysis without altering the original data. The next figure is the figure 8.33, customized view inventory table. So this figure highlights how auditing software like ACL uses logical expressions such as AND or a NOT to filter records. This filtering functionality allows auditors to isolate specific data points such as identifying negative inventory levels. By creating these focus views, auditors can detect anomalies, efficiency, and efficiency and without needing to manually scan through every record. Figure 8.34, the expression builder. So this figure is the expression builder for our data analysis or audit tool called ACL. Protected view warning, a security feature alerts that files from the internet can contain viruses and recommends staying in this mode unless editing is necessary. So, ACL Expression Builder, the main content shows a tool used by auditor to build expression for exception reporting designed to identify specific data issues like stockouts or negative balances. The functions and the variables, the tool allows users to put variable and utilize various functions like mathematical operations, text manipulation, and data formatting to build complex queries. The next one, which is the figure 8.32, view on filtered inventory table. So, which illustrates the use of auditing software to analyze inventory data for exceptions. The table demonstrates using a filtered view to pinpoint specific data exceptions. By flagging these exceptions, auditors can focus on potential data entry errors or management failures without reviewing every record manually. The data displayed includes inventory item details, cost, and negative balances. Figure 8.36, the inventory table stratified on unit cost. So this report appears to be a summary view used in audit or inventory analysis to group items based on their cost. The data is organized by unit cost, showing the count of items and the percentage of total count or value within each cost range. The interface, known likely from a statistical or audit software like ACL, suggests it is used for data analysis, generating summary reports. Stratifying data, ACL lets auditors group records into strata based on numeric fields like unit cost or quantity. This helps summarize data, analyze distributions, and focus on areas with unusual concentrations for better audit insights. For the statistical analysis or ACL supports record sampling and monetary unit sampling, allowing auditors to select random or interval samples. Record sampling treats all items equally, while MUs emphasizing larger value items for files with skewed distributions. For the overall summary, this chapter or this topic provides a comprehensive overview about the relational database concepts, including file organization and access methods. It It then explained how CAATTs such as EAM and GAS are used for data extraction and audit testing, the features, advantages, and limitations of the embedded audit module were discussed along with the common functions of GAS. And finally, the chapter is introduced ACL as a leading GAS tool and highlighted its key features. Finally, a prominent example of a GAS tool detailing its key features and common functions in a professional audit environment.